And now we have our last vlog in the series on rates, and this is about the effect of a catalyst on the rate of reaction. Now, here we have effect of a catalyst on rate of reaction. Now, before we start, Mr. McLaren, what do you understand by the term catalyst?
Now, a catalyst is a substance that speeds up the rate of a chemical reaction without itself being chemically changed at the end of the reaction.
Okay, fine, that's a great definition. Now, here we have a very typical reaction that you need to know about. Hydrogen peroxide breaking down into oxygen and water. Now, if you left that to do it on its own, it would take a very long time. So we use a catalyst, and the catalyst is
Manganese 4 oxide.
manganese 4 oxide.
Represents actually the charge or the valency of the manganese, and do remember it is manganese, not magnesium.
Yes, that's a common mistake. And the 4 is very important. It has to be in the name. You can't just choose to leave it out. Manganese 4 oxide. Right, Miss McLaren, could you write the chemical equation for this reaction, hydrogen peroxide, forming oxygen and water?
With pleasure, Dr. Bourne. Hydrogen peroxide, I use a lot of that with my hair. So we have hydrogen peroxide. It's a bit like water, but it's got an extra oxygen. And then it breaks down. Oxygen is a diatomic molecule. And then we have water, which is H2O.
And what do you have to do now?
And then we have to balance the equation. So we actually put a 2 here, which means we've actually got 4 hydrogens.
Yep.
So we've got 2 here, and we multiply by 2, which means we have 2 oxygens, and then we have 2 there, which gives us 4 oxygens.
And you've got 4 on this side.
That's correct. But, Dr. Bourne, I think I've missed something.
Have you?
The manganese 4 oxide. So
Just wait there. Do we write the catalyst into the chemical equation?
Oh, right. I defined it as something that speeds up the rate and itself is chemically unchanged, which means it's not in the reaction. So I normally put it above.
Just put it above. Never write it into the actual chemical equation. So it's very important. Okay, so you can put it above the arrow, but don't write it into the equation. Okay, right, so we know it's chemically unchanged at the end, the catalyst. So how does it work? What's it actually doing?
So that's different from the definition. So what a catalyst does, for a normal reaction, you have the reactant that's going to products, and it has to overcome, or the reactants have to have sufficient activation energy to react successfully.
Yes.
So what a catalyst does is it provides an alternative route for a reaction which has got a lower activation energy.
Lovely. So you draw that on there.
So for example, it could be that.
Right, and mark on the activation energy.
So the activation energy would be like so, and that is the lower activation energy.
So the original pathway is still there, it hasn't gone away, but there is now an alternative route that the chemical breakdown could take, which has a lower activation energy. And obviously, if you've got a choice of doing the very difficult route or the much easier route, the particles might choose the easier route.
I think I might do that myself.
I think that's right. So in terms of particles, why does that speed up the rate of reaction?
Well, it means that in a reaction you're going to have now more particles which have the activation energy in order to have more successful collisions per unit time.
Absolutely right, because the activation energy required is lower, so more of the particles are likely to have that amount of energy, therefore there'll be more successful collisions per unit time, and that is how your catalyst works. What else do we have to say about catalysts, Mr. McLaren?
I think that's it.
I think that's it.
Sorted.
Very efficient.
Keep it fresh.